Alright, I told you that it's going to be pretty short and pretty sweet. So we're going to talk about blood flow through the heart. You actually know that. So we've got two circles. We've got pulmonary and systemic. Pulmonary circuit delivers oxygen-poor blood to the lungs and collects oxygen-rich blood from the lungs. Systemic circuit delivers oxygen-rich blood to the tissues and collects oxygen-poor blood from the tissues. Are you following me? So, right atrium receives oxygen-poor blood from the tissues, from systemic circuit, relays it to the right ventricle, which sends or delivers this blood, pumps this oxygen-poor blood into pulmonary circuit to the lungs. Left atrium collects oxygen-rich blood from the pulmonary circuit delivers it into the left ventricle, and left ventricle pumps it, the oxygen-rich blood, into the systemic circuit. The blood flow is directed by valves, like this atrioventricular valve, valve between atrium and ventricle, or this semilunar valve. You with me so far? So this is the direction of blood flow through the heart. Right ventricle receives the blood from superior and inferior vena cava. Right ventricle moves that blood in right atrium receives the blood from superior and inferior vena cava. Right atrium pumps that blood into the right ventricle through the tricuspid valve. Right ventricle pumps the blood into the pulmonary trunk, which branches into the pulmonary arteries, and blood goes through the pulmonary semilunar valve. This blood, you see that it's deoxygenated, reaches pulmonary capillaries where it is saturated with oxygen. Oxygen-rich blood flows back into the left atrium through the pulmonary veins. It enters left atrium, and then left atrium pumps it through the mitral valve into the left ventricle. Left ventricle pumps the blood into the aorta, and blood crosses aortic semilunar valve. Blood from the aorta reaches all the tissues and then is collected into the vena cava. The cycle starts again. Does that make sense? Something that is often underappreciated, but the volume of blood in the pulmonary and systemic circuits, volumes are equal. At every minute you have same amount of blood in these two circuits. There is a mismatch, and there is more blood in one circuit and less in another. We call it congestive heart failure. Pulmonary circuit, as you can imagine, is pretty short. It's pretty short, which means that the pressure in the pulmonary circuit is low due to the low resistance. Systemic circuit is long. Resistance in systemic circuit is high, so the pressure is going to be high. And if you would look at the structure of the left ventricle and we saw it in the heart that we opened on Tuesday. Left ventricle has much thicker walls. Does that make sense? Are we clear? Last circuit that I want to mention before we kind of wrap it up is coronary circuit. So coronary circuit delivers the blood to only heart muscle and only when heart is relaxed, because when heart contracts it squeezes coronary blood vessels. Arteries originate at the base of aorta, and there are two coronary arteries, the right and the left. Okay, so left coronary artery supplies the left side of the heart. Right coronary artery supplies the right side of the heart. You see that coronary arteries branch a lot. One coronary artery that's very easy to spot is anterior interventricular artery. It runs between the ventricles. It supplies the blood to anterior wall of the heart. Now, blood is collected from the cardiac muscle by the cardiac veins, and it is dumped in the coronary sinus. In terms of the anatomy, for the exam, I think it's on the study guide, but nevertheless, left and right coronary artery, anterior interventricular artery, and coronary sinus. That's it. For anatomy, you have to be able to identify those four. Am I clear? The pattern of coronary circuit is different between different people because vessels are often connected to each other by anastomosis. Remember connections between blood vessels called anastomosis? Anastomosis provide so-called collateral blood flow pathway. So if you have an obstruction of a small coronary vessel, anastomosis will allow the blood to go around. This doesn't work for large arteries. If there is an obstruction of the anterior interventricular artery, that means a massive cardiac event. Does that make sense? Now, so coronary artery occlusion is the massive, it's a huge cardiac event. So what are the types of occlusion? First is angina pectoris. It's a partial occlusion. Manifests as the chest pain usually. Pain behind the sternum. Does that make sense? This is called angina pectoris. Complete occlusion of the coronary artery is myocardial infarction. Now when I say, look, when I say coronary artery, I refer to any artery in the coronary circuit. Does that make sense? It may be an occlusion of the smaller arteries, or it may be occlusion of one of these major arteries. So, two types of myocardial infarction. One is classic myocardial infarction type 1, when atherosclerotic plaque or a thrombus somewhere else in the body rupture and enter the heart, or they can be formed in the heart due to the atrial fibrillation, and then this thrombus, with or without plaque, accidentally enters coronary circuit. And when it gets stuck in one of the blood vessels, it causes myocardial infarction. Does that make sense? Type 2, sort of less classic. One is vasospasm. In some individuals, vasospasm can be so dramatic and so prolonged that it will essentially cause ischemia and death of the cardiac muscle. Does that make sense? Basically narrowing down, and it never relaxes back. Well, not never, but for a long time. Atherosclerosis of the coronary arteries. If it's sort of left unattended, atherosclerotic plaque may eventually block the blood flow through one of the coronary arteries. And another type of type 2 myocardial infarction is supply-demand imbalance. If the heart requires a lot of blood flow and occluded blood vessels cannot provide sufficient, cardiac cells start to be hypoxic, and that leads to massive damage, which we will discuss, not now. Cells die, and when cardiac cells die, they're replaced by connective tissue. And when they're replaced by connective tissue, cardiac efficiency decreases. So multiple myocardial infarction actually make a person really prone to further cardiac insufficiencies. In terms of physiology, I want you to know the mechanism of myocardial infarction. Okay? Now, here's what I want you to do.